Hello, everyone. We can slowly go ahead and start to get started. My name is Ben Balter. I lead GitHub's government outreach efforts. I just want to quickly introduce the panel here. This entire conference, we've been talking about source code. We've been talking about software. But the idea is that the concepts, the ideas, the philosophies, the workflows that make the magic of open source possible don't have to be limited just to software source code. You can take the ideas of forking, of pull requests, of issues, of tracking who made what change when, and apply that same concept to data, to policy, and how we as a society govern ourselves. And so with that, I'm going to turn it over to these three much smarter folks to talk about different case studies of how they're using GitHub and using the philosophies of open source to open up data in their own projects. So with that, I'll turn it over to Hide from the Japanese Geospatial Information Authority.
Okay, thank you. Okay, can I start? Thank you, Ben. My name is Hidenori Fujimura, and I'm from Geospatial Information Authority of Japan. We are the Japanese National Geospatial Information Authority. And we run web map service called GSI Maps since 2003. We provide topographic maps and also photos and semantic maps, such kind of maps with landform classification and disaster information. We provide actually more than 1,200 layers from GSI maps. We use open standards such as 3P map tile names or GeoJSON or such kind of specifications. And according to the open data strategy of the Japanese government, we used government standard license, which is similar to CC BY. So our data can be embedded in any online or offline systems. So I hope in the future our tiles become the first secondary background map in GeoJSON mapping function in GitHub. And I move on to open source. How do we mappers think about open source? We would like to provide a choice for our maps wherever there is a need for mapping Japan. So we build upon and release open source software and open standard to reduce the reason maybe not to use our maps. Here is a list of our repositories from GitHub. We provide source code of GSI maps itself, and we provide tiles downloader, such kind of repository we have. Let's move on to the disaster information. Our mission includes providing disaster information to provide the full nation direct access to the information about the situation. We typically receive 4 times much tile access in the period of disaster response. And we support further disaster response by related organizations. Our support includes provide 3D handouts like this 3D model using 3D printer. This is a kind of volcano, one volcano from our institute data. And also we provide 3D handout of flat area like this. Like this. This is a kind of field support from our organization. Here are some examples. On September 27th, Mount Ontake is erupted. We conducted emergency photogrammetric flight from Mount Ontake normally.
Sorry, he needs to fix the mic.
So let's continue. So, okay, I can go back. Okay, can I continue? Last year, Mount Ontake is erupted, and we conducted emergency photogrammetric flight to Mount Ontake. Normally, photogrammetric flight fly over the damaged area, but in this case, our airplane had to fly around the volcano with the eruption. So we took many photos, and because there is many people concerned about the situation, the access to the GSI maps exceeded the capacity of the service, so we needed to develop a bypass system as soon as possible. So just a few hours, we developed and deployed our system to bypass our GSI map system. Oblique photos and insert images are available from this GitHub Pages, GitHub Pages. And also, we used photoscenes to add more intuitive view of our photos. And there's many people who is impressed with this intuitive view of the volcano. And last month, there was a flood from broken dike in Joso city. We flew a drone over the flooding river to capture the situation like this. And this movie is available for download and also available at YouTube. And we organize obtained data in GSI maps like this. If you click the yellow icons, you can get the aerial photos, and this is also our open data. And in blue line, we provide disaster area. And we will also capture the recovery of the dike by a drone, and this movie is also available to anyone. And we say we are successful to capture also photos of different stages of recovery in this case. And it turned out that comparison between also photos in GSI maps was not so easy. So we decided to develop a special site to provide comparison between old photos and new photos. And again, we used GitHub Pages to provide comparison between the also photo in day 1 and day 18. Like this, and it takes just a few hours to provide this kind of photos, website. And our tweet to announce this site got many retweets. It's good. And we say open collaboration is beginning to work. Our also photo comparing site keeps improving by social coding. The first version does not support Internet Explorer, but some external developer contributed a pull request to support IE9 and more. So we are happy with that. And now there is a new issue for iOS 9 because it's a new OS, and so we opened the new issues. So your contributions are welcome. We see more open collaboration by open data. Our also photos for the big earthquake in 2011 were included in open source version of the East Japan Earthquake Archive, Shinsai mapping.jp. And our also photo is used as the background of the archive website. And in addition, there is news archive, or there is a message from residents. So I can say our open data obtained new values by open collaboration with external developers or universities. In conclusion, I say GSI build upon and release open source software and open standard to maximize the use of its open data. And GitHub Flow and GitHub Pages helped us a lot. And our open data are producing more values by collaborating with external developers. That concludes my presentation. Thank you very much.
Hello, everyone. My name is Danny Whalen, and I'm the co-founder of a company called Remix, and we build software for municipal transit planners. So transit planners use our software to plan their systems, route adjustments, realignments, schedule shifts directly with the municipal transit agencies. And I'm going to talk about a slightly different angle of open data, which is that when governments open up their data, specifically, vendors can then provide value back to the government by building on top of that data. So they get a direct feedback loop and direct benefit from opening up their data. My company is called Remix. These are my co-founders. We were in Code for America last year, which is an organization that partners with municipal governments on technology projects. And this project was a side project originally. And when we put it out, we saw pretty overwhelming interest from professional transit planners. And we really didn't expect that. And there was enough interest and that we decided to turn it into a company. So it's been about a year now. We were in the winter 2015 class of Y Combinator, and since then have grown to, there's 9 of us pictured here, but there's 10 of us, and we are all working on building software specifically to solve this problem, better public transit. These are some of our customers. So we work with over 50 transit agencies around the world. And they are using our software to plan their transit systems today. Some of the local ones you might have heard of: AC Transit in Oakland, Samtrans and VTA in the South Bay. These have been incredible partners. They were some of our earliest partners, and they use our software to do what they need to do day to day. And there's some others on here I'm sure you've seen. So this is how transit planning originally used to start. So traditionally, planners would print out large maps and draw route realignments on these maps. And they could all stand over it, and that was the collaborative, being in the same room, collaborating over a sheet of paper. And actually, it wasn't great, but it got the job done for a long, long time. And that's how you figured out where the routes go, and a lot of intuition went into this process. The next step in this process would be something like a very large spreadsheet. This is probably not an uncommon thing. It's a very general tool and applicable to anything. So in particular, this spreadsheet is 5+ years old. You can't see it, but there are 200+ tabs here. So it's a lot of data. I think the collaborative angle here is that it lives on a shared drive, right? So that we can work on it. And this works for a long time. This has worked for a long, long time. It's how they get things done. So we realized that this was a problem, and they wanted, the transit planners wanted better tools. So we built something for the web that they could use to build better transit systems. So it's a web-based tool, and you can go in and pull in existing routes. Anybody take the 22 Fillmore here? Woo! All right. So we'll go make a couple adjustments to the 22 Fillmore. We'll pull it down, make it go down Mariposa. So this is, you would have then come down Mariposa. Let's pull in the rest of SFMTA for some context. Should be about 85 routes in total. I'm sure you recognize a lot of these. So we're also on the fly calculating peak buses required to run this system, and then revenue hours per year, among other things. So if we wanted to get an idea of the accessibility from where we are to the rest of the city using only public transit, we could do that with this tool, where we'll, in the background, build a graph of this transit system and then traverse that graph and figure out how far you can go in increments of 15, 30, 45, and 60 minutes. And now on the fly, you can do quick accessibility analysis of your transit system. Make a change, it will adjust. This was not possible before. So none of this would be possible without open data. Everything is built on top of open data. We use OpenStreetMap data. That drawing action is using a routing engine called Valhalla, built by a company named Mapsin, and that basically is a graph built up of the road networks from OpenStreetMap. So you get that nice drawing action that honors one-ways and knows the street network. We use census data. That's how planners validate that their routes are accomplishing the goals that they set out to. And then what I'm here to talk to you about today is just one piece of the open data we use, which is data called GTFS, General Transit Feed Specification. If you've ever used Google Maps to plan a transit trip, or RouteC, or Swift, or another app like that, those are all built on top of GTFS. And then many of them integrate with GTFS real-time. But I'm going to speak specifically about GTFS today. This is a common format that can describe transit systems. It's a pretty portable format, just CSVs in a zip file. It's basically a massive schedule table with the accompanying geospatial data. And together, it's the complete picture of the operations of a transit system. So this is basically what it would describe. So on some specific date, maybe today, a bus running the SFMTA Route 48 Kintara. Anyone ride the 48 Kintara here? Oh, we got one in the back. There you go. So 48 Kintara heading inbound towards the Sunset District. We'll stop at 22nd and 3rd Street not too long from now. So you could catch that bus if you wanted to. But you see, the subject of this data is a vehicle and its location. And what planners need is something else. So we have to take this data and transform it into something that planners can use to do their job day to day. So I'll just show you that transformation. What a planner cares about is that on a weekday, passengers waiting to ride the 48 Kintara in the afternoon should wait no more than 15 minutes to board. So the subject went from a vehicle and its location to a passenger and their experience riding this route. So we take open data describing the movement of vehicles around a city. We transform it into a description of human experience. Because in the end, this is what planners care about. Planners care about crafting better experiences for the humans that live and work in these cities. So now, rather than paper and pen, rather than a complicated spreadsheet, planners can collaborate over an online tool. They can move quickly. They can share these things. They can export them to any format they need to integrate with any of the tools they need. And they can go back and forth and together come up with the best possible route. And they can do this quickly and efficiently. So the other big point I'd like to make here is that us as a government vendor, open data allows us to provide value to our customers on day one. We did not sign a contract, set up a 3-year waterfall integration plan to hopefully someday provide value to the people who are helping make our cities better. Because of open data, day one, you can pull in your existing routes, make changes, see the impact of those changes. Thank you for having me, GitHub. We are Remix, and we are happy to chat afterwards. We're also hiring. I hope that's okay to say. Yeah. So reach out to me. I'll be around. So thank you very much for having me.
Hi, I'm Abhi. Before we get going, though, a couple things. So Danny was a Code for America fellow, which means that he spent a year of his life quitting his old job, took a living wage stipend, and went and worked for a city government to build software. So that's public service. So if we can just get a round of applause for that. Second thing is, this is probably the worst time to have a session because it's right after lunch, it's on Friday, you all want to go to bed, I'm sure, or not pay attention to anything what we're saying. So I will do my best, I promise, to keep this very brief. And I don't really have as interesting stories as these guys, but I thought there's 2 stories that I would tell you. So my name's Abhi Nemani. I spent some time at Code for America, and most recently I was the chief data officer at City of Los Angeles, running a couple different things: data analytics, open data, and digital services. And what I want to talk to you about was how I found open source so interesting and valuable in a public sector environment. But before I do that, let me just, a show of hands. Anyone here work for government in the past? Anyone here want to ever work for government in the future? OK, we're going to change that in the next 7 minutes, I promise you. OK. Well, let me tell you a story. So I came to Los Angeles after they launched their open data program, and Danny talked about open data beforehand. This was the open data portal beforehand. Great picture of the mayor. He's a really good-looking guy. So the average user numbers were about 1,000 uniques a month. Not exactly what you'd expect for the second biggest city in the country. So, I went around then when I started, and I started asking people questions. Like, so what do you think about the data portal? What do you think about data? What's going on? Like, what do you like? What do you don't like? Et cetera. And the biggest thing, and it's funny, the person who told me this is the secretary in the office that I worked in. So you would think that she would know this. The question she asked was, Abhi, what is data? And that's a fair question, right? Like, a lot of people don't think about that. Is like, what does data mean? What is it? And particularly when you go to a data portal, like, all right, I'm supposed to understand what data is and what you're talking about here. So then I spent a lot of time then talking to other people and researching and redesigned the data portal. And made this, which isn't terribly better. But this is the new data.la.org. And what I did, if you can tell, it's pretty clear. If there's CartoDB representatives in the audience, they should be clapping right now. No? OK. Is I put a map front and center, because people look at maps as data, right? They look at, and this is what you were talking about beforehand, right? Is that people look at GIS information as the way you visualize data. So whatever, I did that just because I thought it would make sense. But here was what was really interesting. I really hate the animations on this. I've always tried to kill those, and they never go away. But here's what's interesting. So the bounce rate. Are you guys familiar with technology? Do you guys know what a bounce rate is? No? So the bounce rate was around 50% on the first site. It dropped to 5 when we redesigned it. And that's like a very small tweak, right? Like, I just changed, I put a map at the top and made the colors a little prettier than that weird blue thing. And you got people to stick around very much more, right? So I think I bring that up as a general point as people who are thinking about open data and how to make experiences around open data, is that the user experience, how you tell the story, matters as much as all of the data that you're publishing, right? We've published 400 data sets, right? But no one was using it until we made the site more compelling and more useful. So that's one story. Again, I'm going to try to be very quick here. So anyone familiar with the phrase ComStat? No? So it sounds really heavy and crazy. It stands for computerized statistics. It started about 10 years ago in New York. There's a guy, Bill Bracken, who was the head of New York police at that point. And New York at that point had a real problem around crime. And so he had a kind of simple idea, which for all of us here, because we're all technologists, will understand. Actually, I'm not really a technologist. I'm a poor man's technologist, but whatever. He had a simple idea, which is instead of just sending 10 cops here, 20 cops there, 30 cops there, every day after every day, he said, let's look at the data. So he built a simple program called ComStat, where every week they'd look at what crime is happening in different parts of New York, and then redeploy resources based on that data. Right? It's what all of us would do in any kind of traditional analytics shop at a startup or at a company, right? We would redeploy resources based on issues, right? For cities, though, for government, it's a radical idea. And if you go to New York now, it's very different than 10 years ago, right? And in part, it's because of that new program. So when so actually I'm no longer in the city of Los Angeles, but my former boss, Eric Garcetti took office, he said that he's going to institute ComStat, this idea, for every department. Every department. And so what do you do if you want to do that? Right? You build a dashboard so you can track it, right? So this was the first dashboard that they built. So anyone want to guess what the average monthly usage on that was? Just guess. Please, someone, just throw me a number. It was basically just me. So it was so bad and not useful that the mayor, you're going to love this, had a separate dashboard built for him to track the performance of departments. And it looked like this. This was his dashboard. It was a piece of paper, and yeah, you can see my markings on it because I just couldn't understand it, that looked almost kind of visually interesting, but was not at all. So this is what he had every month delivered to him to track the status of departments. There's 4 sheets of paper. This is one of them. There's 3 other ones. And so then on January 1 or 2 this year, I got an email from the chief of staff, and she said, Abhi, hey, you know how to do technology stuff. Can you make this digital? I said, sure. Give me 2 months, a little bit of time to do some testing. And she said, Abhi, I need it in 3 days. This is government, which is why you all should go work there. It's wonderful. I'm really not making my point about the other thing, but all right. But the thing is, and I wish my friend Jessica Lord was here. Is she around, Ben? No? I'll tell you in a second. But so we built this in about 4 days. It's lamayor.org/dashboard. And it's all open source code. The maps are CartoDB, the charts are D3, and everything else, and this is what's interesting, is just Google Docs. So the way all of those other pieces on the dashboard work is literally just random different government officials plugging in numbers into Google Docs, and it makes the site work. And the reason I want to talk about Jessica, who I wish was here, so she was a Code for America fellow in the past as well. She built a really nice tool on top of Tabletop called Sheetsy. So it makes it trivial to take data from a Google spreadsheet and put it on a website. And I got to tell you, when I made that move, when I made that shift to make it easy for people to just change this anytime, whenever they wanted, it was eye-opening. Like, people just changed the way they thought about technology because they're like, wow, I can update a website by just changing a Google Doc, which all of us know is not that hard. But for people who don't know technology, people who are unfamiliar with it, it's interesting. So the other interesting thing about it was, once we started building this, I'll tell you a secret. This is being recorded, though. Well, whatever. I don't work for the city. The funny thing was, when I built the thing, we made it internal. I hosted the whole thing on GH Pages, right? So actually, it was public the whole time. Just no one knew that. And then we made it public by putting a different URL on top of it. But the whole time, it was all there. And that's a really powerful thing. For anybody working in government or thinking about working for government, just putting things on GitHub Pages has actually been really useful. I put 7 different applications we built, and you can check them out at github.com/data-la. And I just put them all there. And didn't have to go through the bureaucracy, the politics, the chaos of trying to get something approved. Because, it's just on the internet. OK, so that's all good and well, right? So I did whatever. I coded poorly. But that doesn't scale, right? You can't just have one guy coding in a city of 4 million people, right? So we built Tech LA, which is a community now of over 20,000 people in the city of Los Angeles using open data to actually make the city work better. And there's one in San Francisco. It's code for San Francisco? Or yeah, code for San Francisco. There you go. Go talk to that guy and join that community. And they're using the code and the data that we're publishing and actually making it better. And I would just say that that would be the biggest thing to think about with all of the great skills that you guys have, all the great talent. Use a little bit of it, to actually help your cities work better, to help your governments work better. And I guess in closing, that's what I would just say is, you can complain about government, you can say it's not working well, but at the end of the day, it's what you make of it. And the great thing about open source and new technology is that you actually can do something, right? So I would just implore you to help make our governments work better. Thank you.
One more round of applause for the panel, please. So we have a couple minutes left. I have a couple questions to kick things off, and then if you have any questions, start getting them ready, because I'm hoping to be able to take a couple from the audience as well. So the one thing I think that was missing, we're all government people, we're all technologists. What does government look like normally, right? LA is a very forward-thinking city. Tokyo is a very technological city. What does, maybe, Abhi, maybe this is a little bit more for you. What does government look like normally? What is an average city, filing cabinets and PDFs at all? How do they process data, closed or otherwise?
Well, so first of all, I mean, so I'm from a town of 10,000 people. I'm from South Illinois. And so when I think about government technology and I think about technology for the civic space, I think about that, not LA, because we have a budget of $24 billion, right? Which is a little different. Which is a little different than most cities. But no, it's actually mostly still that way. And actually, I think the biggest thing. All right, yeah, thank you. When I think about city stuff, it's actually the biggest challenge. Actually, you know this from the federal government level. Is the problem is we too much focus on effectively OCRing paper documents and putting them on open data, and we feel good about that. That's ridiculous. It's utterly ridiculous. And the sad thing is we have tens of thousands, and Danny's a great example of it, of people willing to go use this data to make it better, but we're arming them with pencils and Post-it notes, right? And so I think the biggest thing we have to do is start building digital services, right? So actually making these services that were beforehand on paper and making them digital. So I'll give you one just example, and then you guys can answer the rest of it. So crime data is a big thing. Who cares about crime data? Really, no one? Seriously? Crime? All right. For the city of Los Angeles to get crime data, it takes 18 months from an incident to actually get the real crime data. Because we have to send, literally, I swear to God, a paper copy of the incident report up to Sacramento for the state to transcribe it, and then they send it back down as a digital version. And their backlog is 18 months. That's not tenable. I'm sorry, that just doesn't work. And so that would be the biggest thing I would want to change.
And so maybe this is a little bit more for Fide. How can technologists here in the audience, technologists on the live stream, if they liked your efforts, they want to support your efforts, how can just everyday developers, designers, user experience experts help you do your job and join your community?
Yeah. So our mission is to provide basic data, and we need more application-specific application website. So then maybe people have some value from their service, and that means maybe our data is valuable for the social, for the society.
Are you finding that technologists from the community are getting involved, are helping out, or is that something that you struggle with?
We are struggling to involve, but including joining this session. But now I understand that it is important to talk with developers, technologists outside to get more input from them.
And so probably one more question, and if there's any questions from the audience. Danny, as you're going from city to city to transit agency to transit agency, what's the biggest barrier to adoption of kind of open data philosophies? Is it technical? Is it cultural? Is it systemic? What do you find the biggest challenge in your efforts?
It's a good question. I think the first thing is there can be political risk involved, and there can be privacy risk involved, and government is just very risk averse. So understanding, having a understanding of what the risks are from the government's perspective, and then seeing what you can do to bridge that gap or show that the risk isn't there or how the risk can be mitigated. Taking it from that approach can move things along faster. And it's also kind of just habit. Once you're in the habit of being open and just publishing things frequently, and those tools are there, then that kind of builds and compounds. And I think that this is what we're seeing right now, is that that more and more agencies and more governments are just defaulting to, yeah, let's just put it on the website because there's no good reason not to. And I think that helps.
That's great. I think we have time for probably one question. Yeah.
What's your take on semantic data? We come from the link coaching semantic data world. There's a lot of effort that needs to be do machine reasoning on top of it and put it all together.
So the question was, what's their take on semantic data, data that's linked together that can describe other data and embedded in websites? Anybody want to? And it is machine readable. Anybody want to take that?
Sure. It is a very important where it's kind of a baby step situation. It's like it's going to take some time to get there, but where you can look to some of the larger and better resourced cities for work on that. And I think there's enough proof there have been enough proof points on the private side of things to show that this is a really great way to approach data, and it will just take time.
Yeah, I would just add, I actually don't think this is, so when we talk about proper technology, right, like semantic data, it's nothing that one city on its own will ever be able to do. It's really not the case, right? I mean, even the biggest cities, New York, LA, Chicago, we have teams that are doing this stuff, but there's no way, A, that they're gonna have the best talent that everyone else could have, B, that it's gonna scale, right? And so I think the more interesting thing to think about is how you build those kinds of tools on top of the open data we're publishing, because we're just throwing it out there, right? Build those tools on top of it that actually help do that kind of semantic search, machine learning on top of it, predictive analytics even on top of it. And there's a couple companies that are doing that now. I'd check out Enigma.io. They're really great. Actually, it's partly run by a former CDO for New York. They do some great work. But to me, I would never want just one city to build that model, because I want every city to be able to have access to it, right? And so that's where I think the private sector, consultants, nonprofits, startups, play a really key role.
As for our map data, we develop our data using a specific specification, and each of our data instance have ID, so maybe each features have IDs, so maybe we can build semantic things upon our data, but we have to start such kind of research maybe from now.
With that, I would just say that if you want to learn more about their efforts on GitHub and other open data efforts on GitHub, you can check out government.github.com, which has links to their websites and websites of portals of other folks doing similar efforts in government. If we can just ask for one more last round of applause for this panel's time today, and thank you very much.